Hey class, welcome back. Quarter 2, we're going to start Unit 3. Our first lesson is going to take a look at inequalities. The first thing I would like you to do before we get started is just to review some warm-up questions here. Find the value of the variable in each of these equations. Write the answer above the variable. So pause the video here and try to answer those questions for me. All right, I will be taking a look at those as you turn it in, and hopefully those went well for you. Okay, so inequalities. Let's compare inequalities and equalities first. So an equality is when it has an equal sign, like x equals 2 is an equality. That means that there's one solution, and the solution is 2. On a number line, if you look at an equality, if you have like a number line here, so just a little piece of a number line, when you graph an equality, x equals 2 is just that spot right there at 2. An inequality has an inequality symbol instead of an equal sign. So this one says that x is less than 2. So the solution is all real numbers that are less than 2. On our number line, if we graph the same value, that means that it is all of the numbers to the left of 2, less than 2. And that's what that looks like. So we're going to practice that a little bit more. So first, here are the inequalities. The first one points to the left. This is the less than symbol. If it points to the left, but it has the bar underneath of it, that is less than or equal to. If it points to the right, that is the greater than symbol. If it points to the right and has the bar under it, that is greater than or equal to. And then the equal with the diagonal line through it means not equal. Not equal. So those are our inequality symbols and their meanings. So let's practice a few problems with graphing inequalities. Show x is, this symbol here is the symbol for greater than. So show x is greater than 5 on a number line and then give 4 examples of a solution for x. So when graphing on a number line, I'm going to just put a few values. So I'm going to go -2, -1, 0, 1, 2, 3, 4, 5, and 6. Maybe I should have started at like a different value. But I want to graph all the values that x is greater than 5. So I'm going to start by putting an open circle at 5. And then the values that are bigger than 5 include like 6 and 7. And so I draw the line and the arrow to go towards those values. So greater than would be to the right. Then I leave the circle at 5 open because it is not equal to 5. 5 is not greater than 5. 5 is equal to 5. So we have an open circle for greater than. This one says, show x is, this is pointing to the left, this is the less than symbol. So show that x is less than 23 on a number line. Oh, and I forgot to give 4 solutions for x. Okay, so let's do that quick for this one. Solutions. We could have x could equal 6, 7, 8, or 100. Anything bigger than 5, greater than 5. X cannot equal 5 because 5 is not greater than 5. These are just possible solutions. There's infinitely many that would work. Okay, so let's show that x is less than 23 and then give some examples for solutions. So this time I'm just going to start at 20, 21, 22, 23, 24, 25. X is less than 23, so I start by putting my circle at 23. And then I think about whether or not I fill it in. Since 23 is not equal to 23, I leave the circle open. And then less than, I look at the values on the left of the number 23 are like 21, 20. And the numbers on the right are 24 and 25. Since 21 and 20 are less than 23, I draw my arrow for my graph towards those numbers. And so for solutions could be 22. You could have a solution in between here like 20.5. That's less than 23. You could have 0 is less than 23. Anything to the left of 23. Negative 10 would be another example. But you cannot have 23 because 23 would not be a solution because 23 is not less than 23. 23 is equal to. That's why we leave our circle there opened. For x is greater than or equal to negative 2. So that's what this symbol points to the right and has the line under it. That is greater than or equal to negative 2. So negative numbers start out like this, like negative 4, negative 3, negative 2, negative 1, then 0, then it goes positive 1, positive 2, positive 3. So I start at negative 2, draw my circle at negative 2. This time, since it's negative, x is greater than or equal to negative 2, since negative 2 is equal to negative 2, this time I shade in my box because negative 2 is a solution. And then greater than negative 2 goes to the right because 0 is bigger than negative 2, 3 is bigger than negative 2, so I go to the right. Negative 4 is actually less than negative 2. Negative 4 is less than negative 2 because if you think about like temperature, negative 4 is colder than negative 2. That might be a good way to remember it. So we go to the right for greater than, and it's a closed circle this time filled in because negative 2 is a solution. So for solutions, I could say x could be equal to negative 2 this time, or 0, or 3, or 15, or 1,000,000. All of those values would be greater than negative 2. Okay, this one says show x's, this is the less than or equal to symbol, 12.5. So x is less than or equal to 12.5. And so I'm going to start with 10, 11, 12, 13, 14. You can label your number line any way you'd like as long as you count by the same number. So I'm counting by ones. You could count by twos, count by threes, but a number line has to have even intervals. So I could have counted by halves too because 12.5 is right here halfway between 12 and 13. I start by putting my circle at 12.5. This time, since it is equal to 12.5, I'm going to fill in my circle. That tells me on my graph that it includes that value. And then less than, the numbers that are less than 12 are on the left on the number line, so I draw my arrow to the left. So x is less than, so all my solutions for x are any number along this side. So if I could think of another decimal, like this number right here, 12.25, that could be a solution for x. X could equal 12.25. X could equal 10.5. X could just equal 9, or x could equal 0 all the way down. Any value that is less than 12.5 or equal to 12.5. So this one could also, x could also equal 12.5. So there's multiple solutions for that inequality. This inequality could also be written as 12.5 is greater than or equal to x. So that is another way to write it. Sometimes we write the number on the left, and 12.5 is bigger than the x values then, so greater than or equal to. So if you flip it around so that the x is on the other side, you do have to flip around the inequality so it faces the other direction. Okay, that's all the examples for me. So you give it a try now. Tell me what it means in words, and then practice graphing it on the number line.